right, so we have 14 seconds before we get started, according to my computer. I'd like to start this talk off with a little bit of a rant of traveling to foreign countries with a touch bar iMac, or my Mac. I have a dongle over here that is way bigger than my little clicker thing. I have a dongle over here. In my bag, I have a dongle for my power, which is dongled again so I can get this fancy European power. So this is a struggle to get here today, so I hope you all appreciate the effort I went through. So the first thing I want to start off with is a lesson, life lesson. You want to write talks, you want to talk at conferences, you want to be like me. The first thing you need to learn how to do is make a provocative title. YAML is for computers. Ksonnet is for people. What does that even mean? That makes no sense. But the people who are reviewing, and I have reviewed for a lot of conferences, love fancy titles. They also like a lot of content whenever you're talking about your synopsis. So this is a little bit of a lesson. Make your titles a little bit provocative, and you will rise to the least of the mid-pack. So, hello. This is me. The reason I put my picture in my slides is because one day these slides will end up on the internet, and I want people to know that this guy created them. So I'm Bryan Liles. I'm an engineer at Heptio. I write software. I like cars and hip hop. I notice I don't say software. I do that for money. It's fun, but I like cars and hip hop. I code at Bryan L on GitHub, and I talk smack at Bryan L on Twitter. So here we go. So I think any project, anything you're going to do, you need to have a goal. If you don't have a goal, what are you actually aiming for? What is the end of your task? So actually for this talk, I put in some goals. And we're going to talk about GitOps, and we're going to talk about managing any application. And then we're going to talk about making declarative application management easy. Easy in air quotes, because this is a tech talk, so this is not easy for your non-technical partner. And then also democratizing the management of applications. As you notice, I use a lot of big words here. This is a proper syllabus, but we'll get into it and I'll explain everything. So the first thing here is GitOps. What is that? Anyone here know what GitOps is? Actually, I'm actually challenging you all. That's a made-up term. Other than Weave, the term GitOps is just a thing. It's something that you think it is, and I think most of us in this room are on the same page. So basically for GitOps, what we're thinking is there's a person, or whatever, black emoji, that they make a change, they take that change, and they put it in their Git repository, and they create a PR or whatever your system does is pull request. And then there's a review and approve cycle. And then after that, it gets committed to whatever your master or upstream branch is. And then it gets magically applied to your whatever. That's what I'm thinking of GitOps. So basically, it's taking some kind of configuration, describing it as a text, and then making the updates to text, and then reviewing it like you review your software, and then automatically applying it to wherever it needs to be applied. Just wanted to put that out there. So, on to the controversy. Working with Kubernetes is working with YAML. And it's funny, my boss is literally one of the people who created Kubernetes, and I like the guy, but I look at him every single time. Like, YAML, this is a long troll. YAML is actually great, and I'll go into why it's great later, but it's a long troll. So let me show you why it's a long troll. So we have as a deployment, and this is just a standard deployment. I put a few extra things in here just to make it a little bit more verbose. But what we're doing here is we're deploying this Docker image called HTTP bin. Everyone knows what HTTP bin is, right? Well, if not, you will know in about 4 or 5 slides. But we're going to deploy this app to our cluster, and we're done, right? Well, of course not. We can't just deploy a deployment. We have to deploy a service because we want to actually be able to talk to this web app that we've created. So we also go ahead and we create this service. And once again, services, I really do enjoy a service configuration, but still, it's more YAML. And we're going to put the service on port 80, but now, how do our users get a hold of it? Well, we could have put it on a node port and let that go, but we did not do that. In this case, we're going to define an ingress. And the ingress type is not important here. This actual code would work with Nginx ingress. It would work with contour ingress. And the reason I say contour is because Heptio makes contour, so I have to actually use it sometimes. But it's not important. But what we have here is this ingress, and we're going to serve this site on http://bin.myk8s. And the secret here is that the example is on my Minikube. Locally, I've configured my DNS, so anything in the myk8s domain goes to where I think Minikube is at that particular time. So that's a deployment. And just as a little thing here, I see a lot of people do it, but this is for posterity. You're going to see me run K a lot during this demo or during this talk. I want you to know that K is just an alias for kube control. It's not an alias for kubectl or kubectl. It's kube control. Just putting that out there. So let's look at this. I'm a horrible typer. And if you look at my tweets, you'll notice I miss words, I misspell words. I understand it, but between my brain and my fingers, my spinal cord is lossy or something, so I lose out. So all my demos here, I'm not a Kelsey Hightower, I'm going to do this live. I did this live, and then I recorded the best take. And sped it up, because who has time for that? So let's actually do this, and this is just an example of a deploy with kube control. And as you can see here, I just do it really quickly, and I do it over and over again. It's just apply this directory. You know, we've seen this. This is actually the appeal of Kubernetes. I can actually take this declarative manifest of deployments, ingress, service, on disk. I can run this one command with this -f, and what do I get? Well, I get this. This HTTP bin website running on my local cluster on the Minikube, not on this thing, this is just my travel Mac, but on my other Mac at my house. And really, what do we have here? Well, we have it running on that URL, and we have this website. And the reason I show this is because I think anyone who works in the web domain needs to know about this app. It's HTTP bin. It's just HTTP, if you're doing things with HTTP, you're going to want to maybe spoof some traffic, or maybe see if you can actually see some traffic. So it's a great app, and it's super simple, super small, so I like to use it. So I hope you all were paying attention to the manifest that I created earlier, because if you come to my talk, you're going to get quizzed. What namespace were those objects deployed to? Yell it out, it's fine. Default, that's right, I didn't actually add one there. But what if you wanted multiple versions of the deployment service and ingress in your cluster? Well, what could you do? Well, you could be like, hey, Brian, you're not that smart. I'll take that directory. I will copy that directory to another directory. I will go into that thing, and then I will add a namespace to each one of those, and I will do kube control apply, or apply-f again. You could, but what if you wanted to do it again? Well, Brian, I could copy that directory to another directory, change the namespace to whatever I wanted to, and do it again. Well, yes, but is that optimal? I don't know. Maybe it is for you. I want to give you options. Then the next thing is, what if you wanted to deploy the service deployment and ingress to another cluster? And here's the thing. I love a lot of things about Kubernetes. Somewhere under here, I have a Kubernetes hoodie. I have a Kubernetes patch. I have lots of Kubernetes shirts. But one thing that I am not happy about in Kubernetes land is the kubeconfig file. And not that it's bad, because it works. But the problem is, if you touch 2 clusters, it's great. If you touch 15 clusters, and then you delete 4 of those clusters, and then you add 3 more clusters, and you delete 1 cluster because GKE makes it really easy to bring clusters up and down, what do you have? Well, you have a mess. So what if you wanted to deploy to another cluster? Well, you could actually just go kube control, and then you can go config, and you can set another context, and then you could just apply. Problem solved. Well, what if you wanted to use a different ingress setup in production versus development? And what I mean by this is, well, what if you wanted to actually just change the ingress out? Like in my staging environment, I might be using Nginx. But we want to make sure that we have Contour in production. Or maybe we're actually using Nginx in our development environment and we're moving to Contour. So we want to actually figure out how we use that. How do we actually make those changes? Or even better yet, I used to work at a bank, and there's all sorts of crazy firewalls that you can get at banks. And in production, we ran all sorts of web application firewalls, sometimes more than one, but we never ran that in staging. So how do you manage that configuration at deploy time? And here's another one of my favorites. What if you wanted to apply a node affinity rule to your deployment? Node affinities are actually not hard. You can do them in like 4 lines of code, but most people don't get them right the first time. And node affinity is actually the easy one. What if you wanted to do a pod affinity? I cannot do that from memory because I know that one of the keys is literally this long when I type it out on my computer. And it's like preferred during something, 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 something. Your users don't need to know that. That is actually a Kubernetes thing. And then also, we'll get to this final piece. What if I want to change this? And generally what it is my host is h3bin.myakates. What if I want it to be something else? How do I actually change that? And easy, the answer is I can just go edit my files. But we're in a declarative world now, so we should not be doing it this way. There are better ways. So real quick here, infrastructure as code. I think we're all in agreement that this is a good idea. We saw what happened with the CF engine. I mean, it might predate some of you all, but we had some Puppet, we had some Chef, we had some Salt, and then we had some Ansible. Those were all good. I actually really enjoyed the environments that I was able to build with those. But one problem that we came into is that what we realized before, with all the ones that I just named, up to where we are now, we realized that procedural was a problem whenever we were doing our infrastructure deploys. And not that it's bad or wrong, it just that happens is that when you're doing a procedural, you tend to generate cruft over time. So we went to declarative, and Kubernetes went declarative with their object files, and then Terraform went declarative as well. So I'm not talking trash about Ansible. I know Red Hat's here. I actually really do like Ansible. I use it, but it's not right for all problems. And specifically where it's not right is for creating Kubernetes objects. I enjoy that someone actually went out and created this stuff, but the problem is it only works within their context. It only works in that narrow band that you can do it. And also with Terraform. Terraform is great for bringing up nodes in everywhere. I like to talk about Terraform because I use my software, so my software is on lots of computers. But when it comes to actually doing Kubernetes, notice that in every single case where you're bringing up Kubernetes objects, they actually have resources like Kubernetes config map. They actually have Kubernetes service, Kubernetes namespace. We don't want that. We want flexibility in our code. So what's the answer? All right. I'm going to talk about ksonnet, but I want to show you ksonnet real quick here. So what I've done here is sped this up a lot, is I've created this ksonnet app, and I am deploying my deployment, my service, and my ingress. And what you've noticed here is that besides this last line here, because I did this on purpose with this JQ weirdness, what I've done here is I've touched no software. And I'm not saying that I have this magical tool here that can actually solve all your problems with a generator, because that's silly. But here's the start. I want easy things to be easy, hard things to be possible. And what we're doing here is we're trying to remove the need from YAML from your day-to-day. Not get rid of it, but just remove some of the need. So just to show you, we have our site. And this is more of my proof. This is social proof that this all works. So what we've done here is, this is a new site, new URL, different than the other URL. But back to my questions. What if you wanted to actually deploy multiple versions of this deployment, this ingress, and this service on your cluster? Well, guess what? ksonnet has an answer for that as well. So let me show you something here. Once again, not changing any code. With ksonnet, we have this concept of environments. Really what we're saying is that an environment is a cluster and a namespace. You can have n of them, n greater than equal 1. With 0, it probably doesn't work very well. But what we can do is, now that we know something about your cluster, we know something about your environments, we can add a new one. So I added a new one in a same namespace, same cluster. And now what I've done here, without changing any code, without doing any crazy thing, changing any YAML, what we've done here, once you actually, this is a Safari issue. I moved to Safari recently because Firefox took too much memory, but Safari is brain dead, so you actually got to type HTTP in there. So what I'm showing you is that I deployed this thing to my cluster again without changing anything. But now you're saying, hey, Bryan, you're just showing me magic. This is all canned. Why is this important? So now I think I have some of you intrigued. Let me talk a little bit about what ksonnet is. Ksonnet is what we have is a ksonnet app. I'm not sure why we call it a ksonnet app. You actually can't execute it, but it's a collection of things that you can use to describe your deployments to your Kubernetes clusters, not just cluster. So generally what we have are components, and I'll go into that. We have libraries of code. We will pre-generate some code for you, or you could have code from somewhere else. We'll talk about that one in a second. And then we have vendored code. Vendored code is code that you may have created for another project or someone in the community created. You can actually use that. We'll slightly go over that. And then we have this environments thing where we actually talk about the environments that we're working in. So the goal here is really to do this. We want to take your application, break it down to the basic parts, so not just have one application in here, maybe we have 5 applications in here, and then we want to take those 5 applications, put them together in whatever way seems relevant or is important at that point, and then applying them to environments. So right now we have this environment prod, and we have this environment dev. And one more slide on this. What we would also like to do is inside of these components is like actually break it down. So in this case, we have an ingress, a deployment, and a service, and we're actually going to apply those. And notice we haven't touched anything here. So I raised these points earlier, but what ksonnet can do is it actually gets rid of the need to know what namespace. The namespace is the environment. You can actually remove that. You can remove that piece of variable code from your configurations. But what if you wanted multiple versions? You see that I just deployed multiple versions. You can just create a new environment, deploy it. What if you wanted the deployment, the service, and ingress in another cluster? Once again, use an environment. And what if you had a different ingress setup? Well, one of the power of ksonnet environments is that if you define an application that has component A, B, and C in dev, what you could also do in production is you could define A, B, C, D, and E and use composition to bring them all together. So how does this all work? Well, I have this little gag that I like to run, and I'm only halfway serious about this, but most of the things that we do in modern computer science come from lots of hard work at Google. If anyone wants to debate me on this, I have a long list, and you'll probably go to the end and you'll realize it came from Google. And I'll give you an easy one. Kubernetes came from Google. But JSON It, or actually another one, Prometheus, modeled after something on Google. A lot of these data things we're doing, modeled after something on Google. Not that Google is the smartest out there. They just have a lot of great ideas. But one thing they did is came up with this idea around scripting Borg. And I don't know what Borg configuration language looks like because that's kind of cheating. But I do know that an engineer at Google put together something called JSON It, which is an embodiment of this Borg configuration language. But what is it? Well, here's something that predates me at Heptio. Why is ksonnet called ksonnet? I like to think that just because we couldn't think of a better name, but ksonnet and JSON It rhyme. They are similar. They are not the same thing. But let me show you some JSON It here. So I have a few examples of what it looks like. This is the smallest JSON It document that I could think of. Think about JSON It is basically an extension. It's a data templating language on top of JSON. So any valid JSON object or item or literal or whatever is valid JSON It. So on the left, I have some JSON It. On the right, it'll either evaluate to JSON or YAML, depending on what the output is. So this one, I have an object, empty object, left, right. This one, now I actually have a key and a value. And you notice on the right side that it actually rendered to a YAML object. JSON It also has a standard library. I don't know before I started working on this project if I ever wondered if JSON could have a standard library, but now that I see what JSON It has in it, I'm actually wondering why doesn't my data libraries have standard libraries? And the reason I bring this up is because you have data. We all understand some principles of functional programming on data, like just modifying data, creating something new. JSON It has this built in. So in this next example, what I'm going to do is I'm actually going to take this object, and instead of spitting out the whole object, I'm going to spit out just the fields of the object as a list or as an array. And in this example, what I've done is I have two things here. I have a function and a conditional. So now, something that else I thought I would never want, but now that I have it, I find it amazing. I can actually create functions inside of my data. And I can take those functions and I can create new data. So the example here is that I'm returning an array, and one time I'm calling it with hello with no arguments, another time I'm calling it with an argument, and notice that the outputs are different based on the conditional. Another thing that I can do here, and this is where we start getting interesting, is we can take objects and then we can combine them with other objects. So I have this O1, which has a foo bar, and then my output is O1 plus this new object. I'm using a little bit of syntactic sugar in here and not eliding the plus symbol, but that's what I'm doing. And as my final example in this realm here is I'm actually taking an object, and I'm going inside of this object, and I'm actually modifying a key inside of an embedded object. So Bryan, why do I show this? Well, what we do inside of ksonnet is we use these environments to actually build Kubernetes objects. Remember, your Kubernetes objects are just YAML. So we're actually using constructs from programming and other things, not data templating, but we're actually building new things. So the power that we're bringing to the table means that we can have a lot of things. We can make hard transformations easy and impossible transformations possible. So to bring this back to KubeCon, what I have here on the left is a deployment. It's pretty long, but just showing you that JSON, definitely does the right thing. And just here is I'm introducing parameters where I have this parameter where I say my replicas are 42, and then inside of my spec, I actually say that, look, I can say that it's 42, and notice that when it renders it out, it just renders out the object. No more Jinja, no more Go templates. I just want to take a little sidebar here. I am very grateful for all the great projects that use Go templates, but as a seasoned Gopher, Go templates suck. They're not great. They are great for, I don't know, but it's, I'm thankful that our Go friends created them, but I'm not going to use them anymore. So why do I talk like this? Well, here's something. Does anyone know what this is? I'm sure some of you. It's the spec. It's what's in swagger.json if you actually go look at it. It's the Open API spec. And what we've done as a community is we've described all the endpoints inside of our Kubernetes API, and we've made them JSON. Well, because we've done that, what I can now do is take that and I can convert it to JSON It. And why would I do that? Well, here's why I would do it. Now, and this is something that we're exploring inside of ksonnet land, is now I can use code to actually build my objects. And I'm not advocating this all the time. I actually prefer people to stay simple, and use simple JSON-based or something closer. But think about what this allows you to do. And I have a great example. So imagine if you were, earlier I mentioned node affinities. And applying a node affinity to an existing object is not hard. Like I said, I think it's about 4 lines of YAML that you have to go find and indent in. But what if you wanted to do this, and what if you wanted to make this available in a generic way? Well, what we can do is, inside of JSON It, is we can actually write a node affinity library. And this file is probably 100 lines long, just to make sure that we capture all the cases. But then we can export this object as a function. And then what we can do is we can add it as a node affinity. And the best thing that we can do after that is that we can add another value as well. And this is one of the powers. Notice I'm not talking about ksonnet, I'm actually talking about the powers of JSON It here. And this is why we've used JSON It as the base of ksonnet, because what it does, when you are freed from the burdens of actually editing YAML, you can create some pretty interesting abstractions that can be applied in novel ways. So, answering that question, but moving on. So what about the existing ecosystem? So I've been up here for 25 minutes talking about YAML is not great, it's hard, we're using this JSON It thing. Well, why do I do that? Well, because YAML is for computers. And I did ask Joe Beta about this, and he balks every time I say, hey, you know, why did you long troll us with the YAML? And he says, well, you know, really, yeah. But he says, what else could we have done at the time? And actually, we've done a lot with the YAML. So YAML is for computers. Humans can deal with it, but YAML is for computers. YAML's not bad. But it's not great for me, at least. I can't speak for all the humans. But one thing that what I will say is that it's in heavy use. And it would be awkward for me to say that ksonnet is this interesting project for doing all sorts of configuration for everything Kubernetes, but then to not be able to actually use the existing ecosystem. So I said, you know what? Challenge accepted. This right here is a config map in YAML. It's arbitrary. I don't think you could actually use this for anything. But what I've done here is I'm going to show you something pretty interesting. And this is ksonnet 0.10, came out last week. Notice that you can list the components. And then what I've done is, since all of our, we like the -f, I added an import command to ksonnet. And now, notice what I've done. I've imported that YAML. What it did is it actually brought the YAML in, it put it in the right place, in the right component directory, and then it created an empty parameters that we could fill in later. And that's all it did. But notice that I can actually render YAML alongside my JSON It. And this is important because any new project that comes along should be able to, we have to be able to embrace the past if we're going to move forward in the future. We do not want to alienate. So JSON It, or ksonnet actually does have full YAML support. You can drop it in and it will actually render whatever you give it. So moving along, I actually want to talk about ksonnet in your environment. So remember earlier when I was talking about deploying ksonnet from your dev to your prod? Well, there's reasons why we like this. A lot of companies do actually not deploy, or a lot of teams, a lot of projects actually don't deploy their projects to just one place. They actually deploy them to multiple places. And I used to work in this bank, and I'm not going to talk about it because they don't pay me anymore, so they get no name drops. But I worked at this bank, and we use something called CMDB. A lot of enterprises use CMDB. And what we had to do was we had to tag every single asset with a project, the owner, and its purpose. So what we did also put into ksonnet is the ability to say, use an environment, not only use that to deploy to a particular location in a cluster, or a particular namespace at a particular cluster, we can also tag items, all the items. So we have global labeling per environment inside of ksonnet. But we can also do even more. I didn't create slides for this, but I wanted to talk about our registries. So I was talking about being able to create software for others. So with ksonnet registries, you can actually create code. Like I created the node affinity stuff earlier. What you can actually do is take that code, package it up, share it. Other people can take advantage of it. And the thing is, it doesn't have to be shared publicly. It can be shared privately as well. The best thing is the code that I didn't have to write. We have this concept in ksonnet called prototypes, which are basically starter files. So if you don't want to actually write a deployment out, we'll write it for you, and then you can fill out the rest of it. It goes along to the point that some of Kubernetes is not accessible. I actually look up a deployment most time when I'm creating it. A config map too, because I don't remember all the keys. We should be able to create some of that for you and then get you started on your way. It's all about leveling the playing field, democratizing development on Kubernetes. Another neat feature is that we can validate your objects. Before we apply them, we actually see if they're valid. You can apply invalid objects with kube control, and it'll tell you. ksonnet will as well. But the neat thing is that it'll tell you in the context of where it was applied. So I look at ksonnet as a project that was introduced sometime last year. But what I'm really looking at ksonnet is where we can go next. And this next slide is a big one. And what it is we are going to, in this next iteration, so sometime in June, we're going to support Helm charts in ksonnet. And this is a weird one, because people are like, Bryan, why would you do that? You're competing projects. Well, if you say that, I would actually say that you're not paying attention to where the industry is going. This is open source. We write software that we hope people will use because it is useful. A lot of our phones run Linux. No one here is writing new operating systems anymore that isn't Google or something weird in Russia or China. No one's doing that anymore. Microsoft has even decided, you know what, that Linux thing is not that bad. So what I've looked at is that I could actually go out and create this whole hierarchy and all this stuff for importing, like I want to have a MySQL thing inside of my ksonnet project. I could actually create that infrastructure. Now what I've done is I've actually fragmented the community. And really in the apps community for Kubernetes, we're all trying to accomplish the same thing, but we're all attacking it at different levels. So what I wanted to do here is say that, hey, you know what, the Helm charts, they got a chart for everything and they're vetted. So we're going to use those. The next thing we're going to do is have linting. And the reason we want this is because, like I keep on bringing up the pod affinity, and the reason why is because a lot of issues with people maintaining pod affinities, they just type them in wrong. Even if you go to the Kubernetes documentation right now, you might not get all the options. If you read it long enough, I think you might get it. But we're solving problems. We're not trying to figure out pod affinities. We actually always have a bigger problem. So ksonnet will actually, because we know the structure of your software, we'll just lint it for you. We know what it looks like, and we can do that with YAML. We can do that with Helm charts. We can do that with JSON It. And another thing that I wanted to introduce, and actually we have it working, but it's not in the main line right now, is the concept of overlays. Google has a project. I don't know what it's called this day. It used to be called Conflate. I'm not quite sure what it's called right now. But customize. Is it with a K still? All right, customize with a K. Google has this thing called customize with a K, and the novel feature of it is that it can overlay. You start with your YAML, and depending on the context, you can actually overlay. ksonnet has this ability where we could actually say, I want to actually add a new pod without an initialization controller to a sidecar to every one. We could just overlay it in there. You can basically overlay anything. And then also diff. What is the difference between what I have on disk versus what is in my cluster? We will be making that amazing. And the last two items here are VS Code integration. We do have a VS Code plugin. We wrote it for JSON It, but not for ksonnet. Next month, we will be releasing a VS Code for extension for ksonnet, which is first class. And the final thing here that I would like to add is ksonnet is. Notice that I didn't go into ksonnet. ksonnet is like a 2-hour topic. I had half an hour, so I just wanted to talk about. I was trying to actually show the vision of where we're trying to be about declarative management. But really what we want to do is do a ksonnet spec talking about really when you're talking about declarative applications, what does it look like? How do you actually build them? And then also, instead of leading with your problems, we'll tell you problems that we think ksonnet should solve, and then we can point you direction from there. So this is meant to be an introduction of ksonnet, just showing you that, hey, we are actually out here thinking about this problem and actually developing tools that are for the user. I invite you all to go to their website. But more importantly, and this is the most important bit, this is about people. This is about software about helping people. This is not software to get GitHub stars or anything like that. So come to ksonnet Slack. I'm Bryan L on there. I will meet with everyone who wants to talk with me to tell me what's wrong with declarative management and applications in Kubernetes, because I'm interested in the problem, not the software. The software is only a tool. So please use me to help you be better, and that's all I can ask. Thank you. So we have 1 minute. I can take 2 questions. If anyone, right here, and I'll repeat it. So the question was, can I deploy custom resources with ksonnet? Yes, actually you can. The custom resource, so you needed your own controller, but a custom resource is only YAML. So you can deploy that. We can manage it. It doesn't really matter to us. Right now, you won't have all the great introspection because getting that schema back is not something that's built inside of ksonnet, but we're looking at how to do that. We're currently working with the Kubeflow team. Actually, if you go look at their demo in the Google booth, they're using ksonnet right now, and the Argo team and the workflow team, the workflow tool from Intuit and Applatix, those are both using it, and I have Cert Manager deployed all over the place using CRDs. One more question, right here. Why don't I use what? Did you say fabricate? So is fabricate the tool that was used for generating configurations before? Is it fairly old? Or am I thinking of something else? Huh? So why don't we use it? I actually don't have a great answer. We just don't use it. But if you come up here and tell me a good reason, I will actually go look at it, and then I'll have a great response for why we don't use it. So thank you all. I know I'm standing between you and drink time. Come talk to me now, or when you are all out drinking later, I'm here to answer your questions. Thank you.